Hi there, this is video 622. We are now looking at systems of linear inequalities. And that's a very fancy way of saying we're going to graph more than one thing at the same time on the same graph. Okay. Give me an example using linear equations. So imagine here's you. This is a big lake. And here's you on your sailboat. And you and your sailboat are going in this direction. And this is your sailboat. And there's a big old freighter, huge freighter. And he's going in that direction. Okay, it's important to know when those two things are going to cross. And depending on speed, you might not want to be there at the same time. So if we had equalities, we could actually graph this in terms of lines, but we're going to have inequalities, so we're going to have chunks that we're going to be shading. The nice part about this is that there's really nothing new. All you're going to do is you graph the first one, and then you graph the second one, and where the two shaded parts overlap, that's going to be your feasible region. So the feasible region at the very end is where there's a double overlap. That's the new stuff. All right, so let's get at it. So we'll do the first one here. So x equals y, and our y value. All right, we're going to change that. So 0, 1, 2. So 0 is equal to y, 0. This isn't very challenging, but I made it that way for you. The one thing I suggest to people like doing all the math first and stuff like that, I find I'm more successful if I do one completely and then I do the second one completely. I've just seen where people get confused and they suddenly have like 6 or 8 dots on there and they're like, I don't know which belongs to which line, and it's just bad. So there we go. There's our first one. So 0, 0. Oops. So you can see. And 1 and 1, and 2 and 2. And there's our line now. Our equation said is just a greater than. So we're going to graph it with a dotted line. This line up nice. And I'm going to put 1 beside that, so later on, if I forget, this is number 1. All right, now we need to do some checkpoints. What am I going to do? I guess I'll work down. God, I can't use my usual checkpoint of 0, 0. Just on the line. All right, no. Let's go, I don't know, 4 and 1. Okay, so x is greater than y. 4 is greater than 1. So yeah, it looks like this is probably the right side of my graph. Checkpoint 2. All right, I'll pick one from up here. How about that one? And that's going to be 3 and 6. Now, if I wanted to, I could pick from down here or over here. It doesn't matter as long as it's on the opposite side of the graph, but I don't want to include negatives. I don't have to. That's just making my life more difficult. So x is greater than y, 3 is greater than 6, and that's enough. So for this question, I need to shade underneath, and it says it's real. So I'm going to take my And again, the highlighter. And a new highlighter. And I'm also just going to do that. So remember which is you can see the highlight. Okay. All right, so that's number one. Now number two is my x. 2x is equal to y plus 1 and y. So 0, 2 times 0 is equal to y plus 1. 0 is equal to y plus 1 minus 1 minus 1. Y is equal to minus 1. Don't lose your negatives, folks. Two times 1 is y plus 1. 2 times 1 is 2. Y plus 1 minus 1 minus 1. 1 is equal to y.
What is it that I have that I take those for? I can't think of the word.
Pardon me. I'm in the middle of a video.
Oh, sorry.
That's okay. I'm not sure how much that got picked up. Claritin. Claritin is the word you want.
No,
Antihistamine?
no, the problem.
You have allergies?
Allergies.
And this is what happens when you're working at home. Say hi, Henning.
Hello.
Henning is my husband. He's also my co-host apparently today. Some days it's Bean, some days it's Henning. It's all good. So 4 is equal to y plus 1. He's actually pretty amazing because I'm doing this and it's kind of like, yeah, you're allowed to be around. Just it's our house, but be quiet. All right, and our last one is 2 and 3. One thing you can do is, I'm going to be crazy here and I'm going to use a pen. I'm going to graph in a different color. So I got 0 and minus 1. And then I've got 1 and 1. And it's okay, it's the same that we hit the, what's the word I want? Same point as we used before. And we got 2 and 3. And I'm hoping that all comes out. And this time, check it out, check it out. Oops, move down so you can see it better. We got a less than or equal to sign. So I get to draw a solid line this time. And I'm going to mark that number 2 right now. But this is 2 over here. And it 2 is real numbers. But I guess I got to do my checkpoint. I just think to keep things, to not get all messed up, I'm going to pick some new checkpoints. I'm not going to use my usual 0, 0. All right, let's pick one there. So that is 4 over and 5 up. Yep. Say that was 4 over 5 up. We need our equation. And you know what? Don't go here. Go back to the very beginning. In case you screwed up here, you'll catch yourself. So 2x is less than or equal to y plus 1. So substitute it in. 2 times 4 is less than or equal to 5 plus 1. 2 times 4 is 8. It's less than or equal to 6. So that'd be a big old no. So let's pick one on the other side. Let's do that point. And that is 1 and 7. I'm running out of room here. 2x less than or equal to y plus 1. 2 times 1 less than or equal to 7 plus 1. Yes, 2 times 1 is 2. It's less than or equal to 8. So this is the yes. So this side was the no. This side was the yes. And there's real numbers again. So everything on this side. Oh, this is going to be a messy graph. Maybe by the next video, I'm going to go see if I can find some highlighters besides my yellow one. All right, that is a beautiful piece of art. So what do we care about? We need to know the feasible region for the solution is where the two parts overlap. So where is it both yellow and pen scribbly? So this little widget here, this wedge. You know, I'm just going to color it. I'm going to feel sorry for anybody that just looks at my answer sheets and doesn't watch this video, because you know what, this got really messy. So this part, that wedge there, that is your feasible region. That is your solution. Ta-da! That was a long one, and that is how systems of equations work. Graph 1, graph 2, see where they overlap.